Okay. Today, based on the atoms and molecules, actually in the periodic classification, first atomic structure, after that periodic classification. From the atomic structure as the beginning. So when you are referring the plus one, plus two chapter, it will be first atomic structure. Then based on the atomic structure, periodic classification will be there. So these two chapter combined, we are discussing. First, I explain about the electronic configuration, then how the periods, how the groups, and how we are writing the period, how we are writing the groups, and why we should we discussed before. Now, the atomic, the atoms and molecules, atom and molecule. That means the first, the universe which is made up of two parts. One is the matter, and another one is the energy. The first one we are calling as a matter, and another one we are calling as the energy. In that matter and the energy, only two parts will be there in our universe. So in that, whatever the substance, anything means any substance or any material. So anything which is occupying the mass. So it should have the mass, and it should occupy the space. For example, you are keeping on a notebook. If you are the notebook having mass, and if you keep somewhere, then it will occupy some space. So that's the particular material we are calling as a matter. Next, suppose if the things it does not occupy the space and it doesn't having the mass, then we are considering as a energy. Now we are going to discuss about the matter. Matter, how we are going the history of matter. When you are breaking the matter, we will get the parts. The parts is nothing but molecule. The last stable part is called the molecule or particle. They used to call one word as a particle, or otherwise they can call it as molecule. In that molecule, two different types will be there. So that means in our atmospheric condition means the 1 atm pressure 25 degrees celsius. If it is anything 1 atm pressure and 25 degrees celsius, if any substance exists stable form, then the particular substance we are considering as a molecular form or particle form. So element, when we are taking the metals, gold, copper, silver, and platinum, this and all metals, it will exist in our nature freely, and it won't combine with any other substance. So that metals are considered as a element. Next, noble gas. Noble gas, single element. Single element means either helium. If you take helium or neon or argon, is a radioactive element. So we should not consider helium, neon, argon, krypton, xenon. Up to the radon, this and all is a noble gas. It will exist in our nature freely, and it won't combine with any other element. So it is called a single atom. Next one, two atoms are there. Two atoms, H2 form. So that's why we are writing H2. But the same hydrogen should not form as a H3 form also. Why? Because only two atoms will it will be stable in our atmospheric. F to form, I to form, Cl to form. This and all we are saying two atoms. It will be combined with each other. It will form as a molecule. So two atoms. So it is a two atoms present in the molecule. That two atoms are same atom. So here hydrogen means a two. A nitrogen, if you take N and N, both are and O. It is 2 and F. Only two atoms are connected, but both the atoms are similar atoms. So that's why we are calling this is elemental form of the molecule. And next to ozone. Oxygen you written as your O2, but O2 form is stable and O3 form is stable. But when you are supplying the sunlight, that means ozone layer we are saying no. So when you are supplying the light or sunlight, then it will decompose again, it will form as the oxygen molecule. So O3 also certain extent it will be stable, but most of the time oxygen only stable. Next, phosphorus we are telling. Next highest number in the molecule, highest number. What are the elements? Will connected with one more bonds connected with each phosphorus. Then here one lone pair. Now if I tell, then you will get the confusion. So here phosphorus exists in the four form. Sulfur exists in the round. In the round, sulfur connected with one another with a single bond. Overall, 8 sulfur will be connected with one another. So it is S8. Saying beyond that. Now these are the elements we are seeing as these are the molecule we are saying elemental form of the molecule. That means elemental form of the molecule means a same kind. Same kind means the same atom should exist in the molecule. There is no different. One atom also should not be different. If it is at least one atom, if it is different, then it will comes under the compound. Compound also we are calling as a matter. Compound also we are calling as a matter. Why? Because it's having mass and as well as volume. Now HCl, two elements are there, two atoms are there. Hydrogen one atom, chlorine one atom, but both are different atoms. Hydrogen one and chlorine. Hydrogen one atom and chlorine one atom, so both are different atoms. Here hydrogen, bromine, both are different atoms. Here hydrogen, chlorine, both are different atoms. Here hydrogen and the iodine form of the molecule. Clear, sir? Is there any doubt? If you have any doubt, or I need to go with the flow, then I'll go with the
flow. Yeah, yes.
It is clear, no?
Because of that, like your voice is also breaking, sir.
What's sir?
Yes, sir.
Okay.
Continue. Because of that, your voice is also breaking sometimes. So it is very disturbing sometimes, sir.
Okay. So please, others, anybody?
We are not able to understand what you are trying to say, like, because of your.
Okay. From the beginning, shall I start, or otherwise the elemental form you understand, no?
Yes, sir. Yes, sir. We are understanding it, but at the same time, it's very difficult sometimes. Yeah.
No, sir. Actually, here universe is there. We have the universe. In that universe, two parts will be there. One is the matter, and another one is energy. That clarity, you know, no? One is the matter, and another one is the energy. The matter we are dividing two parts. That's it.
Yes.
Like a human, for example, human means one is a female and another one is the male part. We are saying no, same as it is. As a matter, we are dividing two parts. One is the elemental part and another one is the compound part. Clear? The elemental part means in the particular molecule, when you are breaking the matter continuously, then you will get the last final division as a atom. Before atom, we are saying as a particle. That before atom, we are saying particle. No, that particle only we are classifying into two types. One is the elemental form and another one is the compound form. Okay. In that elemental form means only same kind of atom will be exist. In the compound form means different kinds of atom will exist. So that's what I'm trying to say. Clear? Why? Because
yes, sir.
Based on that, the question will be there. So that's the reason. Next, if it is here, I said metals. Metals, it will exist only one atom. Then it is monoatomic atom. The molecules exist in the singular form. So single atom is a monoatomic. Suppose if it is the two atoms are exist, then it is called a diatomic. Which is the diatomic? Hydrogen, nitrogen, this and all diatomic exist. So this is triatomic. Next, we are saying is this everything is a polyatomic. These are all polyatomic. Suppose in question how they will ask, among the following which is a monoatomic element, among the following which is a diatomic element, among the following which is a triatomic element, among the following which is a polyatomic element. If they will ask the question, you have to identify. So beyond the example, they won't give. This example only they'll give. Clear? If it is polyatomic. Is it clear, no?
Yes, sir. Yes.
Okay, fine. And next case, if it is compound means is a mixture of element, mixture of atom. Mixture of atom means different atoms should be there. If you take one DNA structure or chloroform structure, so whatever if you will take, at least one atom should be different. If it is one atom, different atom exists in the particle or in the molecule, then we are calling as a compound form of the molecule. Okay, then compound form of the molecule means here also we are saying atomicity. Atomicity means number of atoms exist in a molecule. Number of atoms. So how many number of atoms exist in the molecule? For example, you are taking HCl, HBr, HI, HF, this and all, two atoms are exist. So atomicity is 2, but it is not an element, it is a compound form of the molecule. Here you are saying a CO2, then it is 3 atoms exist. Then it is not an elemental form of the molecule, is a compound form of the molecule. In the compound form of the molecule, atomicity is 3. Clear now, sir? This much you have to remember that. And next, NaCl. Now, atom and molecule, and how we are saying about the molecule, how we are saying about the atom. That means what is the story of the atom? Okay, history of atom. The first one we are considering atom. First, who said about the atom and at what base they are saying? Why? Because atomic size will be 10 power of minus 10 meter. So we can't be able to identify that size. That means with directly we can't able to identify. So that's the reason they are assuming how the atom will be, how much size will be, like they are assuming. The first Lavoisier said, if you are taking two elements, that type of element, so this is element and this also element, when you will combine with each other, you will get the compound. Now, mass of the substance, mass neither be created nor destroyed. You can't destroy the mass of the reactant side. This is a reactant and this is a product. This is a reactant product mass. Reactant mass which is equal to product mass. So now, after that only Dalton said, okay, if you are breaking a molecule H bond H, O bond O, if you break O separate and O separate, and after that this two hydrogen it is going to connect with the one oxygen, then it will become OH, HOH you will get. Now how we are framing the molecule HOH, how we are framing. So how we are framing means either you need to break and next you need to add. So if you are breaking and adding only, you will get the molecule. Yes, sir. Any doubt? Tell me, suppose if you have any doubt. Number 7, you raise the hand. Definition of mass means of number of proton and neutron. So how many number of the proton, how many number of the electron, the neutron present in the particular atom is nothing but mass. And if you are taking the elemental mass, that means atom mass, you are taking as a for example, water mass. You want to check the water mass. So first you have to find out the hydrogen mass how much. One oxygen mass it is 16, and next hydrogen mass 18 gram you can say, or 18 AMU. If it is atomic mass unit, it is 18 AMU, or otherwise if it is a gram unit, then we'll consider as a 18 gram. So based on the unit, it is a slight variation will be there. Now this much enough. So if it is if they will ask the question atom mass, then you have to write the number of the proton plus number of the neutron. Suppose if they will ask the question, what is a molecular mass means the sum of atomic mass. Sum of atomic mass. This hydrogen atom and oxygen atom. The sum of atomic mass is nothing but molecular mass. This much one. Clear? Is there any doubt from this? And next. Here, next they given the Dalton. Dalton, according to the Dalton, he said based on the Lavoisier statement, when you are breaking the molecule, then finally you will get the tiny particle. The tiny particle further you can't able to break. You can't able to break the undivisible particle. Undivisible means we can't able to divide further. So undivisible particle is nothing but atom, like he said. Then after that, Thomson said the atom is a divisible and undivisible. It is not a hello. Next, Thomson he proved that the atom is a one part. In that atom, in that particular atom, the protons will be present complete in the sphere. Now electrons are embedded here and there, like a watermelon. He said. So number of the proton and number of the electron both are equal. Number of the proton and number of the electron both are equal. Thomson. Next case, Rutherford said, no, the atom is a spherical shape in that part, and outside particle is called a negative part. So if it is outside, negative part. If it is inside, positive part. So number of the proton charge and the electron charge both are equal, then atom is the stable, like he said that. Next, Chadwick said, take the proton with the proton. Here, neutron should be present. So because of the neutron, the repulsion going to negligible. Then neutron also present. So it is given by the Chadwick. Next, Bohr theory, the electrons, this is the nucleus. Electrons are revolving continuously in the nucleus. If it is lost, electron energy. If it is lost energy, it will fall down in the nucleus. If it is gained energy, it will go away from the nucleus. Then it is unstable. So that's why Bohr said the particular nucleus having particular, first one is the K shell, second one is the L shell, third one is the M shell. Like shell wise, he said is a Bohr theory. The number of electron. Then he gave the formula 2n square formula. So by using the 2n square, then number of electron. So number of electron will be present in the particular shell. So n is nothing but shell number. N is nothing but shell number. If it is first shell means n value is 1. If it is second shell means n value 2. If it is third shell means n value 3. This one already we discussed in the previous one. Up to 18 element. 18 element means from first hydrogen to argon. It is applicable. First atomic number 1 to the 19th element. For example, potassium. If we take the potassium as the atomic number 19. At the time, we have to write the electronic configuration. Means how we'll write 1s1, 3s2, 3p6, and 3d1 we should write. But actually this is wrong. What we should do, we should write 3s2 and 3p6, 4s1, next 3d we have to write. So without completing the 3d orbital, we should write 4s orbital. Statement given by the according to three rules: Un's rule, Pauling exclusion principle, and alpha principle. So based on the alpha principle, they are writing. Alpha principle means n plus l. We are taking 4s and 3d, which is having more energy, which is having less energy. This one understand, no sir? Hello, anyone respond?
Yes,
sir.
This up to argon, Bohr model is applicable. After the argon, the Bohr model is not applicable. The Bohr model is a failure model. Then that's the reason this flow chart given by the Moeller. This flow chart, whatever I written here, this flow chart given by the Moeller. So Moeller, based on the Pauling rule, he said, sorry, Hafer principle. So based on the Hafer rule is nothing but n plus l. N is nothing but, here already know that s orbital 0. L value for s orbital 0, L value for p orbital 1, L 2, L value for f subshell 3. Now 4, it is nothing but n. And next here n value here 4. Next s orbital they give, here d orbital they give. That means s4 plus 0, here 3 plus 2. Then the total here 4, here 5. Then this value is more. That means 3d is more, 4s value less. That's why we are writing the next energy level. 4s is the lower energy level. The value n plus l value equal to 4, but 3d orbital n plus l value equal to 5. So that's the reason we are writing 3d second, 4s first. Okay. So based on that, how we can write the flow chart. So your first period element having only 1s. That means hydrogen if you take 1s1. If it is helium, if you take 1s2. Second period element up to 2s 2p. Third period element 3s 3p 3d. And fourth period element same as it is. So first period 1 year. From here you have to start. Again 2s. Again you have to start from here 3s 4s 3p 4s. Again you are starting from here 3d 4p 5s. Then first you have to arrange the order. How will arrange that? 1s 2s 2p and 4p. So like extra they are writing. Then after that, if any atom, let them give any atom and any atomic number, just you have to fill the electron. If you fill the electron, then you will get the electronic configuration. So s orbital, s subshell will accommodate only 2 electrons. D subshell, it will accommodate maximum 10 electrons. If it is f subshell, then it can accommodate 14 electrons. Suppose if they will give at the atomic number of the element is the 32. Why? Because 2 electron only will accommodate. Next you have to write here 2. Then this also 2 electron only will accommodate. Here p 6 electron will write. Overall 10 electron over. Remaining 26 electrons are there. Here you are going to. So next year you are going to write the 2 electrons. So overall here 2 plus 2. 2 plus 2 4, 4 plus 6 that is 18, 18 plus 2 20. Up to here 20 electron over. Remaining 6 electrons are there. So 6 electrons how we can write here order next 3d 4p 5s. 3d 4p next 5s. Then you have to write here 3d later 4p and next 5s. Right. Next year you will write the 6 what is it, 20 plus 10. So 30 plus 6 36 electron you will write. So this is the electronic configuration of the element. That's it. Okay. Yes.
Why 4s is coming?
According to this rule, sir. According to the I said Hafer principle. According to the Hafer principle, when you are writing the n plus l value, n means the principal quantum number. Number of the shell, I said no, is the number of the shell. This one is the subshell. Which is subshell? L means the subshell. If it is S subshell means L value 0. D subshell means L value 2. When you are adding the number 4 plus 0, 4, this is a 4 and your S value is a 0. So 4 plus 0, you will get the number 4. And 3d orbital, here 3 and d value is the already I given here. For any orbital, 4d orbital will be constant. It is the 2. Okay, then 3 plus 2, it will become 5. Okay, so now the value, 4s value having less value compared to 3d value. So that's why 4s we are writing in the first series, and 3d we are writing in the second energy level.
Sir, why we are taking
sir?
Sir, why we are taking S as 0 and B as 2 and
before I said yeah, correct. Actually, yes, why we are taking 0, 1, 2, that means S orbital shape, that is S non-direction means 360-degree angle, correct? You can't say which direction this one, so that's why it is 0. If it is X direction, and this is Y direction, and this is Z direction, you have 3 direction, no?
Yes, sir.
Correct now, sir? Then how the shape of the orbital, first lobe and the second lobe, first lobe and the second lobe, correct? Here one lobe and here another lobe. So 2 lobes are there. Here one nodal plane is there. Here when you are saying this one is 0, there is no any lobe. There is a 360-degree angle. So here you are taking one lobe. One lobe means a first one lobe. If you are this is p orbital. Next d orbital is the 2 lobes. First lobe. Here one I written only one lobe, only one lobe. Here S orbital, why I didn't write means there is no any lobe. It's a 360, 0 lobe. That's why 0. Next F, when you are next second lobe, next third lobe. This is shape of the F orbital. So that's the reason we are writing F equal to 3. Now you understand, sir?
Yes, sir.
Now it is clear, no?
Yes.
So S means wherever, if it is 1s orbital or 2s orbital or 3s orbital, everything having spherical shape, is a round shape, like a ball, like a tennis ball. So it is a spherical shape. That's why S value always 0. For L, for when you are calculating the L, S always 0, P always 1, D always 2, F always 3. So that's the reason we are writing here. Clear? Okay, next. So electronic configuration, you know. Next one, electronic configuration. Next, we are going to see about the valency. How we can identify the valency of the element 1, 2, 3, 4, 5, this and all, how we can see. In the periodic table, here this is a periodic table. So you have to remember this element. If you remember this element, is more than enough. Hydrogen, first hydrogen, up to 36 element. Just 36 element you should remember order wise and group wise. For example, boron, aluminum, gallium, this and all same group. And carbon, silicon, germanium, this and all same group. And the nitrogen, phosphorus, arsenic, both these 3 elements are same group. This much you have to remember. If you'll remember, then we can change everything easily. Clear? Now, the first case, hydrogen we took, the electronic configuration, it become noble gas configuration 1s2, that is nothing but helium configuration. S1, that means 1 electron. If it is lost the electron, that means that's why I written minus helium configuration 1s1. So that's why valency 1. That's why valency here 1. Next, when you electronic configuration 1s2, 2s2, 2p6. So K shell completed, L shell completed. Next, we are entering in the electron in the M shell. That means M shell is the incomplete shell. Incomplete shell, last shell is the incomplete shell, means that is called the valence shell. It is called valence. Okay, then if it is 1 electrons are there, then we can say that it is the valency 1. Or otherwise, how sir it is valency 1? Why we should write valency 1? Why not even third shell having 3s, 3p and 3d? No, suppose if I'll add these many electrons, then valency also. Why? Because we can't add that many electrons in the particular shell. Removing off 1 electron is easy, but adding off 17 electron, that's why we are saying here removing 1 electron I removed from the shell, then it becomes 2s2, 2p6. Then it is a neon configuration. Neon configuration means a stable configuration. So the valency of the element is 1. Next, potassium we are writing 1 electron you are removing, then it become first shell stable, K shell completed, and the next L shell completed, and the last shell having 8 electrons. If it is 8 electrons are present in the last shell, then it is known as octet rule. That means last shell, if it is 8 electrons are present, that is it is more stable. Here 8 electrons are there, and then it is stable. So that's why potassium valency 1. So when you are taking the first group element means it is hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, everything valence electron 1. Then it is valency 1. Next, same concept, we can go for that. Next other element also same. Beryllium, they are given atomic number 4. Electronic configuration 2s2 they given. So when you are removing these 2 electrons, then it becomes stable. So the valence is 2. And next, boron family. Boron family, everything 3 electron will be there in the valence shell. Then if you remove this electron, that means this electron if you remove, if you make 0, then it will become helium configuration. Then the valence is 3. That's why I said if the valence electron if it is 1, valency also 1. If it is valence electron 2, valency also 2. If it is valence electron 3, valency also 3. If it is valence electron 5, then you have to use the formula 8 minus 5, which is equal to 3. If it is valence electron 6, then 8 minus 6 equal to 2. And valence electron, if it is valence electron 8, then 8 minus 8 equal to 0. This is known as noble gas. Okay, zero valency. Next, in carbon, same. If it is last 4 electron, it becomes next the carbon, especially carbon, but it won't accept the electron or it won't lose the electron. So it will share the electron. The carbon always will share the electron. That's why we are getting the protein chain and many macromolecules we are getting. That is the reason. And next, nitrogen. When you are taking the nitrogen, overall 5 valence you have to add, or otherwise you need to remove 5 electron. Removing 5 electron is difficult. It is not possible. Adding up 3 electron is easy. That's why valency we are saying 3. Same as it is here oxygen, you need to add 2 electron, or otherwise you need to remove minus 6 electron you need to remove. So that's the reason this is not possible. It is possible. So valency 2. Next to fluorine you are taking the valence electron. If you add 1 electron, it becomes stable. That means if you add 1 electron, then it becomes neon configuration. 1s2, 2s2, 2p6. It is a neon configuration. Then it is more stable. So addition of 1 electron, or otherwise you need to remove 7 electron. If you remove 7 electron, it becomes helium configuration. So removing of 7 electron is not easy. That's why we are taking 1 electron extra. So fluorine, always remember one thing. When you are taking the periodic table, if you will take the periodic table, here we will write plus, here plus. Okay, why? Because removal of electron. Here removal of electron, and here removal of electron. But after from this carbon, nitrogen, and next oxygen, fluorine, this and all, electronegative element, and this one is the electronegative element is more, and this electronegative element is electronegative character is less. This side F minus S minus this and all you are saying. Okay, and the special electronic configuration, two elements are there. Special electronic configuration. One is the chromium and another one is the copper. 2 elements are there. So one is the copper element and another one is the chromium element. How the copper, how it is chromium. So copper, if you chromium atomic number 24. So 1s2, 2s2, 2p6, 3s. That only we are following. 1s, 2s, 2p, 3s, 3p, 4s, 3d. Now actually we should write 2p 6 electron, 3s 2 electron, 3p 6 electron, 4s right. Why? Because 4s should complete, then only the electron should go to the 3d level. This is the lower energy level and this one is the higher energy level. So first it should complete here, then only it should go here. But it is not like that. Why? Because off field configuration. Why it is off field? 2, 3, 4, 5 box will be there. So each box, if you will write electron, first electron, second electron, third electron, fourth electron, one more electron is one more box is empty. One more box it will become empty. So that's the reason we are taking off field configuration. When it become off field configuration, same as like your noble gas 3d5, and the same as it is full field configuration. 9 should write, but it won't be stable. 4s1, 3d10 only most is stable. So these 2 electronic configuration very important, and most of the question they'll ask, write the write the electronic configuration of the chrome ask. So these two things very important. Okay, next. Next here, alpha principle I already said. Alpha principle means electron need to fill by increasing energy level. How the electrons are going to fill by increasing the energy level. So based on energy level, it will fill. So the first one is nothing but alpha principle. Here only they given the formula N plus L rule. According to the N value, L value, the electron going to fill. Next one is the Hund's rule. The same energy level. Same energy level means I written here half fill fulfill. No. So same energy level means the d orbital or p orbital or s orbital. If it is p orbital, then 2, 3, 4, 5. And if it is f orbital, 7 boxes will be there. Okay. Now you have only 2 electrons. Then you should not add like this. You should add first electron. Then you should add 1 electron, 2 electron, 3 electron. So you should not add 1. So that's given by the Hund's rule. If it is equal energy level, you are keeping 3 bowls.
Sure.
3 bowl if you are keeping. Yes, sir. You are connecting with the pi equally. Sure. Same as it is. Yes, sir.
Can you please explain alpha principle once again, sir?
Alpha principle. See, sir. Actually, first period element K shell, L shell, M shell, and all we are writing. No. N means you know it is the shell. If it is K shell means N value 1. 1 second. If it is K, 1. If it is n equal to L shell, then it is 2, you know. Next one, in that K, only one subshell is there, is called S subshell. Here, three subshells are there, S, P, and D. How we are writing S, P, D? How we are writing S, P? How we are writing S? Now, for example, here S subshell having only one orbital. Orbital means this is a nucleus, first shell. In the first shell, having only one orbital, the orbital name is called S orbital. The S orbital shape is called spherical in shape. Next shell, two subshell. One is a lower energy, it is called 2s. Another one is higher energy, it is called 2p. Now, S orbital, we are writing spherical. When you are writing the p orbital, it is orientation based on the orientation. Based on the orientation means if you write here S orbital, what is the orientation you can say? It is like a ball you are keeping in the one axis. Okay, three-dimensional axis if you are keeping. You can't say it is oriented either x direction or y direction or either direction. No. Then we are saying L value equal to 0. L value 0 means there is no any node. Now, actually, before only I said the particular region only electron will be present. But electron where it is present, I don't know. That's why I'm saying the probability of finding electron is nothing but orbital. Orbital is nothing but present, but the electron where it is present, I don't know. So I'm taking one circle, in the particular circle, wherever the electron may be present. So the probability of finding space one we are calling as the orbital. That if I take degree, if I take like a spherical, if I take the electron will be present in a particular region in the 360 degree, then it is called S subshell. Okay. Now first, the electron will be present here, and electron will be present here. There is no any electron here, no electron. Then I can say that the orbital oriented in the is the direction. It is not in the y plane. It is not in the x plane. So that's the reason I'm saying L value I can write 1. If it is L value 1 means 3 orientation I can write. One is a plus orientation. Next one minus 1 orientation. Then it is called P Y orientation. Then it is 0 orientation. P is that orientation. So 3 orientation possible. So that's the reason only one lobe, only one type of lobe. It can oriented 3 angle, 3 different way. So 3-dimensional view. So that's why we are writing here Px, Py and the Pz. This one clear now, sir? Hello? Hello? I'm audible?
Yes, sir.
This one clear, no? This much, sir? Next, next is suppose if you will take the D subshell. D subshell means I said D value equal to 2. D equal to 2 I said. That means one axis you are taking. Here two types of lobes will be available. First lobe, the electron probability, electron finding intensity. This direction is possible. Here it is possible. Here it is possible. Actually, when you write the space, this much space you are writing. The electron I can able to find here only. I can able to find here only. I can able to find here only. Or this direction, or here, or anywhere. These places and all, it won't be possible. So that's why I'm saying two orientation. One is this orientation, and another one is this orientation. Two orientation is possible. Okay, that's why L equal to 2. If I'll take the F means 3 orientation, and this one is a third orientation. When I'll take the circle, this is a round circle. In the particular circle, this space it won't be available. Electron, there is no electron. Only here electron will be available, and here electron will be available, and here not able to find the electron here. So that's why this one is called a node. Node is nothing but 0 electron. There is no any electron in the particular region. That's why F equal to 2. The L value of F equal to 2. Then orbital they are writing. How many orbitals? Overall 7 orbitals we are writing. Plus 2, plus 1, 0, minus 1, minus 2, and the next plus 3, and next minus 3. So these many orbital we can draw. If you take the P, then 3 orientation, Px, Py, and Pz. Plus 1, 0, minus 1. This is called the magnet, and this is called a subshell. This one is the P is a subshell. In the P subshell, 3 orbitals are available. This is the F subshell. F shell having 7 orbitals, and D subshell having 5 orbitals. Clear now, sir? Is there any doubt from this?
Yes.
Okay, now we'll go for the question paper. Based on the question paper, we can easily understand that. The question paper visible, no? Okay.
Yes,
Hello?
sir.
I'm audible. Okay. Now here the first question, one atomic unit of mass which is equal to exactly how much mass of the carbon 12 isotope. Carbon 12, that means mass number, carbon mass number 12, carbon mass number 13, carbon mass number 14. So carbon mass number 12 only 90. So 90% is the maximum. And why they selected as a carbon as a reference substance means why they selected all the living things, all the living organism, everything made up of carbon. Why? Because the final, if you take the plant made up of cellulose made up of glucose made up of carbohydrate. So that means carbon, nitrogen, oxygen, nitrogen, this and all will be there. So the final, the ultimate element is the carbon. So that's why they took the carbon as a reference substance. For one carbon, now you are taking the only one carbon which is equal to how many hydrogen? 12 hydrogen. One carbon which is equal to 12 hydrogen. If you take one bud, one side you are keeping carbon, keep, and here 12 hydrogen you should keep. Now the question, what is the mass of the hydrogen? I don't know mass of the hydrogen, but I'm going to compare with the carbon. Then hydrogen, one hydrogen mass which is equal to carbon 12 isotope. Why? Because I took carbon 12 isotope only. No, so that's the reason carbon 12 isotope. Now 1 equal to 12. One carbon equal to 12 hydrogen. Now 1 by 12 equal to 1 hydrogen. So that's why they written here carbon 12 isotope I took as a reference substance. So then answer 1 by 12th part of carbon 12 isotope is nothing but 1 AMU, atomic mass unit. Okay, that's the first question answer. Next one they are given atoms of same element or a different element form of the molecule. Next different means is a compound. The element and compound together we are calling as a molecule. So that's why it is a molecule. Correct, no, sir? Next, this one understand, no? Second question.
Yes, sir.
Second question. Next, which of the following element is made up of same element, same atom? Same atom means neon. It is exist in our nature. Monoatomic, single atom, and argon also single atom, and helium also single atom, and all of this answer. Next, which of the following is a diatomic? Di means a two. And here also 2 is there. So it is a both A and B. So diatomic molecule. Suppose if they ask the triatomic, then you have to select this one. So here they're not asking the triatomic, they asked the diatomic. That's why we selected the oxygen and the chlorine. Next question. The number of atoms present in the composition of molecule is called how many number of atom? How many number of the atom it is exist in the molecule or in the composition of compound or element? Then it is called the atomicity. How many atoms are exist in the molecule? So atomicity means element. Here they are saying as a composition of molecule. Composition of molecule means molecularity. Even in the molecule, how many molecules are exist? So then we are calling as a molecularity. Next, valency and ionicity. Valency means the particular atom they will say. Particular atom means chlorine. If they'll give the chlorine, what is the valency of chlorine? Valency of chlorine is 1. What is the oxygen is 2. And what is the valency of ozone? If they will ask the ozone valency, then you have to write 2 by 3 as the valency of ozone. So like we can write. So valency, one more few other example I'll discuss later. Next class, some other class when we are doing the revision. No, that time I'll give some other examples also related to the valency. Next, atomicity of nitrogen. Atom means N2. So how many atoms are there? 2 atoms are there. Then atomicity of nitrogen is the diatomic molecule. Next question. This question in many competitive exams they will ask. So this question very important. What is the ratio by mass of the element in the water? Water they are asking. First we should know what is the formula of water. Molecular formula of the water. What is it?
H2O.
Hello. Now it is audible.
Yes, sir.
1 second, sir. 1 second, sir. My voice clear now?
Yes, sir.
Okay. So water molecule, oxygen is the central atom, and hydrogen connected with the oxygen in the terminal atom is hydrogen, and the central atom is the oxygen. Now they are asking what is the ratio of hydrogen and oxygen. Now we can write the one oxygen molecule. Each hydrogen mass is atomic mass of the hydrogen is 1. So how many hydrogens are there? 2 hydrogens are there. Then 2. And 1 atomic mass of the oxygen is 16. So 2 is to 16. Now here they are not given 8 or 2 is to 8 or 12 is to 32. But we got 2 is to 16. Then what is the correct answer means? Again you have to simplify the value. This is 2 and this is 16. 1 2s are 2 and 8 2s are 16. Then 1 is value, 1 is to 2, 1 is to 8. Then we will get the answer. 1 is to 8 is the answer. Suppose if they will ask the same question with carbon dioxide, then now we can write carbon mass. Normally carbon mass is a 12 and oxygen mass is a 16. 2 16s are 32. 2 16s. 16 into 2. That means the 2 oxygen is there. Here 12 ester 30 can simplify or not. So we can simplify with the 4. Here also 4. So 3 times 4 3s are 12. And next again you are simplifying with the 4. 8 12s are dioxide ratio. So like that, some other question also they will give. Just you have to write the formula and find out the based on the atomic mass. This is only for atomic mass. Clear? And the question is simple and also somewhat if you don't know the formula, molecular formula, then it is somewhat difficult. Okay, no sir. So that's the reason I said 1 to 36 element you have to remember. So they won't ask beyond the 32. So they will ask in between in 32 element only. So that 36 element you have to remember. So whatever in the periodic table, first period, second period, third period, and last one is the fourth period. If you know the fourth period up to krypton, up to 36 krypton, then whatever the question related to the atomic mass or a molecular formula, we can write. Okay, no? Understand?
Yes,
okay. Next case, what is the what are called the charged species? Charged species means either they are not saying whether it is cation or anion. Charged species of metal. If it is non-metal means it is a negative charge. If you have to imagine in the periodic table, extreme left side, extreme right side. If it is extreme left side, then it is a ions only. If it is extreme left side, then it is a cation. And if it is extreme right side, then it is anion. They are not saying cation and anion. They are saying about the ion, whether it is a positive or negative. They are not asking whether what is a charged species. Then it is called a ion. Okay. And next, what is a polyatomic ion? Poly means I said if it is 1, 2, 3. Mono, 1 means a mono. If it is 1 means a 1 is the mono, and 2 is a di, 3 is a tri, and if it is 4 more than 4, then it is called a poly. Plus 4, overall 5 atoms are there. Here 1 atom nitrogen, and here 3 4. And here what is that? 1 atom plus 4 oxygen atom. This count you should not take. That is a charge. This is the charge. This is a charge. And this one is the number of atoms. 4 is the atom. Okay. Here 4 means you should not consider for a sulfur. You should do 5. Then everything answer. So polyatomic ion means all of this. Next, which of the following is a nitride? Here it is important. When we will call nitride? IDE. So here we have to remember nitrogen, sulfur, phosphorus. These 3 elements only they will ask much time. Okay. If it is nitrogen minus 3, IDE, nitride. If the nitrogen plus 3, then it is IDE. If it is a nitrogen, the suffix they will ask AT. Sulfur valency if it is 2, IDE. Sulfur if it is valency 4, ATE. Here phosphorus also same. Phosphorus means the same. Minus 3 plus 3 and plus 5. So if it is gained electron, here minus 3 means the electron will gain 3 electron, the 2 electron. Here it will gain the 2 electron. The nitrogen will lose 3 electrons. Here nitrogen will lose 5 electrons. Then it become plus 5. This one. And here it will lose 4 electrons. Then it become IT. So this configuration by using the things I'll explain. Here they given NO2 they give. That means nitrogen 1, 2. First oxygen, second oxygen. Here double bond. Here minus. This is the first category. Second category nitrogen 1, 2, 3. First oxygen, second oxygen. This is the minus. And next they give N3 minus. Okay. So that means here oxygen is a different element and nitrogen is a different element. Oxygen different element. Nitrogen is a positive charge. Here positive charge. Here negative charge. So here what is that? Nitrogen negative charge. Then what I said, ID means it will gain 3 electrons. Then answer is N3 minus. Clear, sir? Understand? Clear? Next.
Yes, sir. Yes, sir.
Suppose if I want to repeat, I will repeat. This question just you have to think Nitrogen and oxygen. Nitrogen is a more electronegative. Just you have to imagine the periodic table. Nitrogen left side or oxygen left side. Nitrogen is the left side. Then you have to write the plus. Oxygen is the right side. In the periodic table, nitrogen here next to oxygen. That means oxygen is the negative, nitrogen is the positive. Okay. Then positive means it should not be ID. It should be, what is it? Negative only. Ionized nitride ion means N3 minus. You have to take the answer. Next, what is the formula of hydrogen sulfide? Here also sulfide they give. That means what? Here hydrogen and sulfur. And here hydrogen and sulfur. Here 2 minus. Valency 2 no. Then 2 minus. Then this one is the answer. Here this one is a AT sulfate. This one is an IT. Basha, it is not connected. This one IT. Same as it is, here it is IT, and here it is AT, and this one is a ID. And suppose if they'll ask nitrate, so nitrate is the answer. Nitrate, if they will give, then you have to select B answer. If they would have given nitrite, then you should select the A is the answer. Okay, and this one is the ammonium ion. This. Okay, so which one they're asking? According to that, we need to select. Next, this is called and this is ITE, and this one they won't write this formula. This is wrong formula. They can't write. This is not a correct formula. And next, valence. Combining capacity of an atom is one and another atom is called valency. It's the definition of valency. And next, what is the formula? In that particular formula, what is the name of the compound? Here, this one already I said. Here, the question number 10 itself, last. What is that, sir? Now, based on the question number 10 and question number 11, once try to answer that question. What is the answer? NH4, what we will call?
Say.
Ammonium. Correct? No?
Ammonium sulfate, sir. See.
What, sir? Yeah. It is ammonium. Ammonium, NH4 is the ammonium, and SO4 is the AT sulfate, then ammonium sulfate. Okay, next, what is that washing soda in our daily life? What is that washing soda?
Sodium bicarbonate.
Sodium bicarbonate is a baking soda, actually Italy soda, by adding Italy and baking bread and all they are making. No, for that they will add NaHCO3. This is baking soda. Washing soda means Na2CO3, or otherwise sometimes they will give Na2CO3 dot 10H2O. This also they'll give. So hydrated sodium carbonate only washing soda. That's why what washing soda is a wet nature. That is not can give, or otherwise sometimes they will give Na2CO3 dot 10H2O. And what is the methanol molecular mass? First we should know that methanol formula. So if we know the methanol
So
formula, then we can write
CO3?
methanol for
K2CO3 name.
methanol.
No, sir. Compound name of the option D, K2CO3.
Which question? Na2CO3.
K2CO3. Question number 4, option D.
K2CO3 name you are
Yes,
asking.
sir.
That is potassium carbonate, sir. This is sodium carbonate. Sodium, either they can say hydrogen carbonate, or otherwise sodium bicarbonate. And this one is a ammonium chloride. The NH4 is ammonium. This is a chloride. Ammonium chloride. Okay, no? So now here we are writing CH3OH is a methanol. That one oxygen, one carbon mass, already we know that atomic mass of the carbon is 12. 4 hydrogen we know, one hydrogen atomic mass is 1, and 4 hydrogen atomic, only one oxygen. So it is a 16. So 12 plus 4 plus 16, 20. And here 12. Then overall, how much? This is 4 hydrogen. Methanol they are asking. 4 hydrogen. Now count. What is the mass of the methanol? What is the mass, sir? 32. Okay, 12 plus 20. So overall 32. Overall atomic mass of the methanol. So suppose if they will ask the question ethanol. Why? Because common alcohol is a suppose if sometimes they will give methanol, and sometimes if they will give alcohol. Alcohol is not a methanol. It is compulsory. We have to write ethanol. Most of the time ethanol they will ask. Then at that time C2H5OH. This is the formula. Then how we can write then 5? 12 and why? Because 5 hydrogen and 6 hydrogen. And the next 1 oxygen 16. So 12 to the chain. So overall how much? 2 plus 24 30 and 46. So 46. You suppose if they will ask the question, then ethanol formula is C2H5OH, and in that ethanol 2 carbons, 6 hydrogen, 1 oxygen is there. Then the molecular mass of the ethanol is this much. Next question: how much atoms does is a understand now, sir? Understand no?
Yes, sir.
Yeah. Next, how much atoms does 23 gram of sodium? 23 gram of sodium means already we know that sodium atomic mass 11, and 11 is the odd number. Odd number 11 means 11 into 2 plus 1. So 22 plus 1, which is equal to 23. So 23 means here they equal to W by M, which is equal to N by Na. Here sodium they give Na, atomic mass 23. Sorry. Atomic number weight they give 23 gram, and molecular mass they given 23. Now how many number of the atoms are exist? How many to W by M, that means weight mass. So next N divided by Na. N means number of particles and N means Avogadro number. Avogadro's number. So this is constant. Constant means 6.023 into 10 power of 23. This is constant value wherever. Then now we are using the formula. They give 23. They give, and the mass how much they give 23. So from the atomic mass, which is equal to 23 divided by 23, which is equal to 1. 23 divided by 23, 1. And next, which is equal to N by Na. Na value already we know that. Na value we know. So N equal to 1 equal to N divided by 6.023 into 10 power of 23, which is equal to, then N equal to, this value if you take this side, 1 into 6. N value we found as a Avogadro number. Then here how much atoms does exist in the sodium as means, for remembering purpose you can keep here 2 3 also. It is not a matter. 6.022 into 10 power of 23. This is the answer. And next, atoms are all inactive gases. Inactive means already we know that all the inactive gases having monatomic or diatomic. Or diatomic. So both can be are correct. Okay. So this much today enough, and remaining part tomorrow we'll discuss. If you have any doubt related to that, then I'll explain again. Anybody having that doubt? If you have doubt, tell, we will complete. Then otherwise we can.
Methanol one, how did you explain the methanol?
Next,
sir?
18th question. 18th question also we can explain. Nitrogen. This is already know that nitrogen in the periodic table, right hand side. Hydrogen in the periodic table, left hand side. So right hand side minus, left hand side plus. Okay. Now valency of hydrogen is 1. How many hydrogens are there? 3 hydrogens are there. Valency of hydrogen 1. So plus 1, 3 times. So we are writing here plus 3 means it should be here minus 3. Then the charge, electrical charge on the nitrogen is minus 3. Okay. Any element. Suppose if here oxygen in the periodic table right side, when you are comparing to the carbon, and then this is minus, this is plus. Okay. Plus or minus you made. Next, valency of 2 oxygens are there. This is called the charge. And this is called the number of atoms. Here 2 atoms are there. So that's why with the 2 minus 4 you will get. Then here only 1 carbon is there. Then same number you have to keep here 4. But charge you should write as a plus. Same as it is here also. Okay, clear sir? And next question. What is the atomic mass of the hydrogen? Atomic mass of the hydrogen. Atomic mass they give. Atomic mass means you should write. Atomic mass of the hydrogen means what is it? One formula of ammonium oxide. Sorry, aluminum oxide. Aluminum oxygen. Oxygen valency 2. Aluminum valency 3. Correct? No? Valency of aluminum 3. Valency of oxygen 2. Then this number you have to keep this Al2O3. Clear? Suppose if they will give the question, what is the valency of ammonia? Then N, here H. Now N valency 3, H here and this number here, then this is equal to NH3. Now you are writing carbon C and hydrogen, methane. Then this number here and this number here, then CH4. So same as it is aluminum oxide, aluminum here Al2O3. Then you can write the formula. Suppose the charge on the aluminum, how we can calculate?
-3.
So what is that? Valency here 3. Then here aluminum is in left side in the periodic table, and oxygen is the right side in the periodic table. Then it is minus and this is plus. So aluminum is the valency 3 and oxidation status plus 3. And oxygen is the valency 2 and oxidation status minus 2. That's it. Clear? With the sign if you say that is oxidation status or a charge. If without the sign if you say that is called the valency. Clear now, sir? With a sign, it is charge. Without sign, it is oxidation. Without sign, it is valence. That's it. Any other doubt? Any other doubt? Any questions, sir?
Sir.
Yes, sir.
Hello, sir. Sir.
And
Question number 20.
Practice that and recall whatever we discussed. You can ask.
Hello, sir.
Yes, sir.
Sir, why?
Yes, sir.
Question number 20. Why is it not called aluminum trioxide?
Which one, sir? 20. Question number
Question
20.
number 20.
One second. Aluminum oxide.
Yeah.
Hello.
Yeah. Why is done?
Actually, sir, when you are writing the element, the formula, no. So first one, you are choosing the which is a plus, which is a minus. Correct. The plus always whatever the name you are keeping as it is you need to keep. But minus, when you are saying about the minus, you need to change the name. For example, sodium chloride, you know already very well. NaCl. Sodium chloride we are saying. Correct? Table salt. Now, we should write chlorine. Why instead of chlorine we are writing chloride? Why? Because this is negative charge. As it is you need to keep. Negative charge means you should write either IDE or valency IDE. Next middle valency IT. If it is higher valency AT, sir. So oxygen only, oxygen, you know that oxygen having 3 different forms. O, 2 minus, O, 2, 2 minus. This is called the oxide. This is called the peroxide. And this is called the superoxide. Next 2 oxygen connected with the here 1 minus, here 1 minus. That is called the peroxide. Next 2 oxygen connected with the here 1 by 2, here 1 by 2. Charge of the oxygen is -1, here charge of the. Okay. So the terminal you should write ID or IT or AT. So based on the negative charge. If it is negative charge means you need to change the oxygen to oxide, chlorine to chloride, nitrogen to nitride. Answer?
Sir, there is no trioxide.
Trioxide we should not write, sir.
Oh.
Why actually your question I understand. Al2, the Al2O3 there we are writing. That means the 3 oxygens are there. Trioxide, like a carbon dioxide you are asking. Correct? No?
Yeah.
Carbon dioxide means carbon monoxide, carbon dioxide. Carbon CO and CO2. 2 form we have in our nature. So that's why we are writing carbon monoxide and carbon dioxide. But here aluminum oxide, when you say no, only one there. Al2O not there. In our nature it does not exist. These elements and all don't exist in our nature. So that's the reason directly we are saying aluminum oxide. Directly we are saying sulfur oxide also. So SO2, SO3, sulfur dioxide, sulfur trioxide we are saying. Why? Because these 2 form it does exist. That's why we are keeping separate name. Here 2 form it won't exist. Only 1 form will exist. That's why we are saying Al2O3.
Yeah.
Okay, no, sir. Fine. Okay, sir. Any others having doubt? Yeah, we can upload the video, sir. Someone asked.
Are you going to take?
What, sir?
Are you going to take evening class today, sir?
No, sir. Tomorrow I'll take.
Okay. Thank you, sir.
Okay, sir. Thank you.